Good evening, students. Today we will learn about the new topic of the circle. We will learn about perpendicular drawn from the center to a chord of a circle. How to draw equal chord of a circle. Then we will learn about the cyclic quadrilateral. In previous two lectures, we have learned about the properties of circle, various terms related to circle like sector, segment, major segment, minor segment, major sector, minor sector, diameter, chord, all those things. We have also learned the important properties of the chord and arc, the angle made by a chord at center and on the circumference, that property, or the angle made by arc at one of these sides. A student, we have learned that this circle is a path such that its distance from a fixed point is always constant. That fixed point is the center and that distance is called as the radius. So this we have already learned, the center and the radius. We have learned that any 2 points taken on the circumference, then moving on this circumference, this is our arc. But at the same time, if we draw a line segment joining A and B, a straight line segment, this is our chord. Okay. Another thing that we have learned was the angle made by these chords at one of the segment. If A and B is 2 points on the circumference, O is the center, then joining A to center O and similarly B to center O, these are the two radius, then an angle is formed at the center. Let us call this angle as the alpha. We can also take any point on the circumference in the side of the center. This is making an angle theta. Then it is found that these alpha and theta are related to each other. Means the angle at center alpha is given by twice of angle at their circumference, or angle at circumference is half of the angle at their center. This was very important property that we have learned. Here this angle may be called as the angle subtended by this arc or the angle subtended by this chord. That doesn't make any difference. Okay, student. So whether we consider the angle subtended by the chord or angle subtended by the arc, both mean the same thing. Another thing that we have learned was, if we are considering the arc A and B, and if we are considering a point P on the minor side of the arc, then say P is the point, A and B is making some angle, then for this, the angle, let us call this as the theta. The angle at center we need to look should be from the same direction, means it should be like this one. This one should be the alpha. Okay, student. Then the relation is alpha is equals to twice of theta. Okay. So we have to keep in mind that while relation between alpha and theta, so alpha and theta should be in the same direction, that I had explained. Like here to here you are moving. So this one, first you need to consider the alpha. Based on this, I had given you the questions And based on this, we have also learned that if we consider a diameter, which is also one kind of chord, but the chord passing through the center, that is called as the diameter, then this diameter always makes 90-degree, because diameter is a straight line or a straight line segment passing through center O. So this angle is 180-degree. So at the circumference, the angle will be 180 by 2, means it is your 90-degree. This we have learned. So this point may be anywhere, whether here or even in this segment also you may take. In this case, we are observing this part is our 90-degree, means this is our 180-degree. Therefore, now we need to take in this direction. It is also our 90-degree. Okay, student. This thing we have learned. Based on this, we had also solved so many questions which are very important for examination. Like the central angle was given, the angle at the circle circumference we have calculated, or the angle at the circumference is given and you need to calculate the central angle. This thing we had learned. Or we also have learned that all the angle made by the same arc or same chord at their circumference are always equal. Another was like this one. If we are considering this circle with arc A and B, then whether you make the angle this one or you make the angle on the same arc, let me call this as P and this as Q, then these two angle P will be equal to angle Q. Okay, means if this is the theta, this angle will also be theta, wherever you make. But we have to keep the arc AB, means this same, or the chord AB. If we are denoting this as by angle R, this angle will also be theta. This thing we have already learned. Now, based on this, many questions are framed. Now we shall go for understanding the angle made at the center get divided by drawing the perpendicular from the center over the chord, that property. But before that, just as a matter of revision, a student, please tell me this question, or let us quickly solve this question as a part of our revision of this concept. A student, in figure, find the missing angle or angles. First one is like this one. So let us consider point A and B and the center O. We are given with the angle at any point P, or a student, do not think it is a rhombus or rectangle. Okay, this P could be anywhere closer to this B or A. Let us consider this point as P and this angle B. Let us take this angle as let us take this angle as 105 degree.
105.
Yeah, so it is our 105. What is this angle X at the center? Okay, student, are you getting? This we need to calculate. This angle is your 105. In first case, you have to calculate this one. The second one, consider a circle in which O is the center, A is any point, and B is the other point. Consider this AB as the diameter, O as the center. There is another point. Let us take a point like C, joining this. So B you may call as the point on the major arc AC, you may call like that. Now this is the figure like this. In this case, let us take this angle as 130 degree. Then we need to find the other angle. Let us consider this angle X we need to find. One is this one. The angle X we need to find. Okay, students? This is the angle X that we need to find. Okay? This is my figure number 2. Students, we will do one more question. Consider this as AB and another point as C, joining like this, and also join to this one. If you are given with this angle, this time let me take one of the angle. Let me take this angle as 50 degree. Then you have to find all the other angles. You have to let us consider this as X, this as Y, and this as Z. Let us take this as Z, this angle, and this also as U. So in this case, in the third figure, we need to find all. X equals to what? Y is equals to what? Z is equals to what? U is equals to what? These 4 things. A student, in the first we need to find the X. In the second, you also need to find X. Okay? You are getting that? Second and third are nearly the same kind of question, but I have separated to make you understand that if you are able to do the second question first, then the third is equally easy. Yes, student, please tell me quickly.
75 degree first one.
Very good. First one is 75 degree. Okay. What else? What about the other students? Students? Any other response from any other student? Last I had explained all the concept.
X is equal to 75 degree.
Okay. Let me verify. A student, I'm going to explain the question number 1 once again. Our figure is like this. A student, observe the figure, or let me draw the figure in the reading itself. Our figure is ABPO. A, B, and any point P, and this center as O. So the figure is something like this. Angle P is given as 105 degree. Okay, student? Then we need to find this X. What is this? Students, I had told you, for the angle, you need to observe the angle in same direction. So how this X, what will the value of X? How that can be determined? Students, if you are coming out of this, you are getting that the angle is like this. The angle at P is over the arc AB. Then for this, if we are coming out, then the angle that we can calculate from 105 degrees is this one. Okay, it will be in the same direction. If we consider this as the angle alpha, I'm just denoting. Okay, then what will be the alpha and 105, how they are related? Then since central angle is twice of circumference angle, but this formula is for the same side. Means if you are looking the angle on the straight line, say while you are moving from here to here, then first you will meet to this point. So from this outward you need to take, then over this point you have to take. Okay, this way you have to correlate this kind of angle. But many a time our students are committing mistake that they are just considering this X and 105. So what is here? The bigger angle or the reflex angle alpha can be calculated first from 105. So therefore here the alpha is equals to twice of 105. Okay, student? So alpha is equals to how much? 210 degree. Now after this, the X can be calculated. How the X can be calculated? Yes, student, anyone can tell me? Then how this X can be calculated?
360 minus 200.
Very good. Now angle at a point is 360 degree, because it is like this one. It is like this one. So if you are moving like this, it becomes 360 degree, this entire angle. If this angle is, say, something X, then this much angle will be 360 minus X, and this is alpha. It simply means, if we are considering this angle as the alpha, then it simply means alpha plus X is equals to 360 degree. You can understand this way also. Okay, so therefore in this case X can be calculated by 360 minus alpha. It is our 360 minus 210. How much it become?
150 degree. 150
150 degree. Good. Therefore, what is the answer? What is the value of X? Yes, student. What is the value of X?
150 degree.
Then you people were they saying for this 75 degree. A student, you people were get confused with cyclic quadrilateral. Though I had not taught, but for the cyclic quadrilateral, if the 4 points are like this one, means all the 4 points are on the same, on this circumference P and Q. In this case, if the angle P is 105, then this Q, if the Q is angle X, then this X plus 105 is equals to 180 degree. This is the cyclic quadrilateral, provided this Q lies on the circumference. Okay, so this is the cyclic quadrilateral. But in the question 1, it is the center O, not the Q. Okay, then this X is 75 degree. So please do not mix your concepts. Okay, so for the cyclic quadrilateral, the 4 points should be on the circumference. But if one of the point is center and other 3 are on the circumference, then we need to apply the concept of angle at the center and angle at circumference, that relation. But be careful, considering the angle at the center, it should be in the same direction as the angle formed at the circumference. Okay, so that's why our students are committing mistake, though last day I had explained such kind of question. Okay student, so first question is very easy, you please do it. Now coming to the second question, what will be the value of X? Can you determine? There are various methods of determining this X. Yes student, can you determine? No? What will be the value of X, students? It will be asked. It is so simple kind of question that it is asked every year. Because unless or until you learn all these concepts, it becomes very difficult for you to understand this circle. So students, what are the property of a triangle? Or even if you are forgetting the property of triangle, then just right now whatever we have learned, the angle made at center and the angle at the circumference by the same arc. So students, this is our the second one.
Sir, X equal to 25 degree.
Very good. Any other students? Yes students, what is the value of X here?
25 degree.
Yes, it is correct. Any other student have calculated? Student, there are various methods of solving this question. I am going to solve by 2 or 3 methods. So student, we can apply in method 1, we can apply the concept of angle at center and angle at circumference. For that, let me draw this circle once again. The diameter is here O, A, B, another point C is here. Then joining A to C, this angle X have to be determined. Here this angle is 130 degree. It is given. So student, we can apply various concepts. This part B to C may be joined or may not be joined. Okay, that doesn't matter. But here it is joined, so let me join. Okay, students, what you can understand from this? Students, you can understand like this. If we consider the arc B and C, means AB is this, AC is this, and center is this one. So considering the arc BC, on the arc BC or the chord BC, we have two kind of angle. One is at the center O, this angle, another this angle. Getting? From the arc BC, if you are looking from this, so B to C at the center, this is the angle formed. Okay, but by BC, the angle formed at the circumference is like this one. Okay student, whether this one or whether this one, mean the same. Whatever this angle alpha at the center, if this is the angle theta, we have also learned this will also be your theta. Okay, because on the same arc BC, so arc BC is same. Therefore, the two angle formed, I have drawn one more. Let us consider this point P. So angle at A will be same as angle at P. But here we are observing that for forming the angle at A, the BA, the line is the diameter. So whether it is diameter or not, that doesn't affect. So this thing we have to take care. So students, what we need for getting this X? So for getting this X, we may consider this situation is like this. The situation is like this, where if we are able to get the alpha, then this theta can be determined. Therefore, in this given figure, if we are able to get this angle will be twice of X. So first we need to calculate this angle, Y. So how to calculate Y? Or better is to denote by the alpha itself. So what is the value of alpha, students?
50 degrees.
Good. Because it is forming a linear pair.
180 degree minus 130 degree.
Yes. So first calculate that. So since alpha is equals to 180 minus 130. 180 minus 130. Why so? It is the linear pair.
Linear pair.
Getting a student? So you must be careful for applying the central angle. Now we are observing that moving from here to here, first we are meeting with the alpha, means on this line, the alpha angle is formed. Then this theta angle is formed. And alpha we have calculated as 50 degree. Now this X, which is the angle at the circumference, that can be calculated by half of angle at the center. So just put it, half of 50 degree, it becomes 25 degree. Okay. So this way, the value of X is 25 degree. A student, you must learn these basic concepts of circle. Questions are always framed on this topic exclusively. Whether the other topic are going to ask or not, but this topic will surely be asked. So be careful. So this is the one method where we have calculated the X by applying the relation between the angle at center and angle at circumference. There is other method also. What is the other method, student? Other method, consider the triangle form or nature of triangle form and the radius. Students, here we are observing that AB is the diameter with center O. Okay, it is like this one. Now, students, here we are observing that OA is one of the radius and OC is the other radius. Are you getting? Therefore, if you are going to just draw the triangle OAC, how it appears? Yes, student?
Isosceles triangle.
Very good. It is isosceles triangle, students. Getting now? So, and here we are given with the central angle at O as this value is given 130 degree. So this angle O is our 130 degree. So rather than using any property of the circle, by applying the property of triangle, we can calculate. Here the angle at A, we are considering the x. So this is x. So what is mean by this isosceles triangle? Since OAC is an isosceles
Opposite angles
triangle.
are equal.
Very good. So here this side OA is equals to OC. Why so? Since both
Radius.
are radius, students,
Radius.
radius of the circle, therefore angle OAC is equals to angle OCA. Get it? So while angle A is considered as x, the angle C will also be x. Okay?
X.
So this is x. Okay? Now by angle sum property in this triangle, what we can write?
130
Yes,
plus
sir.
x plus x is
130
equal
equal to
Very good.
180 degree.
X plus 130 degree is equals to
Equal to
180 degree. What is
2x
this?
plus 130.
This is your
2x is
angle
equal to
sum
150
property.
50 degree.
Very good.
X is equal to 25 degree.
Exactly. So 2x is equals to, go for subtracting this, 130. So this implies x is equals to 50 by 2. So it is your 25 degree. Okay, student. So what we are getting exactly same. So this way you are free to apply the property of triangle and property of circle that the radius is forming isosceles triangle, and we can determine the x. Another, it may be asked for calculating the other angle, like it may be asked for calculating this angle. Consider this angle is y. Then how you can calculate this y? Can anyone tell me what will be the y here? Yes, student. Just we have calculated this x is our 25 degree. This is also our x, same as x, 25 degree, because
80
isosceles.
degree.
Now,
80
if
80
we
degree.
apply the property of the semicircle, then we are observing that it is forming a semicircle with diameter AB. So this x means 25 plus y will be 90 degree. Also, here angle ACB is equals to 90 degree. Why 90 degree?
90 degree
Good.
minus 45 degree is equal to
Very good. So therefore here we can write this is the angle ACO plus angle OCB is equals to 90 degree.
yes sir.
Good. And ACO that we have calculated is same as angle X because of the
25 degree.
triangle that we have drawn here.
Yes,
So this is
angle
our 25 plus
25 degree.
this we are considering as the y is equals to 90 degree. So
Angle
y
y equal to
value is your 90 minus 25.
20
It is how much? 60 degree.
65 degree.
Yes. So getting a student. So this way all the angles can be determined if we are known with any one of the angle, whether at the center or whether at the circumference. A student, in this case even this x may also be given and you need to calculate the angle at the center. Okay, student. So this way all the other angle can be calculated. Okay, even by this method we can also calculate. How is that? A student, there is other method also. If you are considering the chord AC, then for the chord AC, for this chord AC, you can observe that the angle at the center is 130 degree. Are you getting? This is the angle formed at the center, 130 degree. And the same chord AC is subtending the angle at B also. Okay, student, this one. So therefore this angle will be how much? This will be half of the angle at the center, getting, with AC as the chord. So this is half of 130 degree. This is also your 65 degree. Now once this is 65 degree, you are getting that both are the radius. OB is radius, OC is also radius. So this angle will also be 65 degree. Okay, because triangle BOC is isosceles triangle. So there are various ways, students, you have to just think for it. Getting no? So you must apply your concept of the line and angles of the previous chapter and the concept of triangles, isosceles triangle, angle sum property of the triangle in this circle. So questions are very easy. This kind of question will be surely asked, undoubtedly every year it is asked. Okay, so you should be careful for applying the linear pair, angle at the center means the total 360 degree, all these things. So this was all about this. Students, any doubt then please ask. I have explained all the way, all the ways of thinking. Now the same thing whatever I had explained in the two, based on the same thing, another question is framed here. Yes students, in this case we need to find X, Y, Z, U, all these things. How we can find it? It's very easy. Students, what will the value of X? Observe your BC.
25 degree.
Very good. So B to C, this is the chord. From B to C, the center is O. So the angle formed at the center, this is given as your 50 degree. At the same B to C, it is also given that the angle is formed at the circumference. Getting? Though this chord BA is passing through center or not, that doesn't affect. Okay, student? Even in this case, it may be asked for this one also. What will be this angle? Say if the question is like this one, find this angle V also. What will be V? This we will also calculate. Okay, student? So whether you are considering this angle as the X, this angle X will be half of the angle at the center, which is 50 degree. Getting? Or even you are considering any point anywhere. This is the V.
X
So
equal
here,
to angle X equal to angle B.
good. So here two things we have to recall, a student. Angle X is equals to angle V. It is one thing. And both of these are at the circumference. So both of this angle will be half of the angle formed at the center by the same chord BC. Are we getting? Both of these are joining their end at the chord BC. Okay, student? Are we getting? It is like this one. So you should be careful. Just observe the figure carefully. Observe which arc is common or which chord is common. Accordingly, you apply. So this will be half of angle at center is your 50 degree. So this is 25 degree. Are we getting? So it is one of the question. Now you are asked with the other values, say Y and Z, all those things. Let me take one more figure. Students, draw the same figure, but be careful. A to B, the another point is our C, the center is our O, now this angle we have already determined, not required. This is our 50 degree. Now let us try to determine this angle. Say angle Y, which is this entire one. Y. What will be the Y? How Y can be determined? Yes, student. What will be the value of Y? Student, you must careful in determining the common chord or common arc. How this is formed? Student, you can understand this is the angle formed like this one. You can see. Say consider AC as the common arc. The center is O. Then joining this A and C at the center, we are getting this angle, one kind of angle. Okay. And extending this AO to B means AB, then going to C. Okay, student. So here we are getting these two angles are formed over the common chord AC. Okay, so right here common chord AC for angle at center and circumference. But students, while applying this, what is the angle required? The required angle is this angle. This is the alpha. Then this will be the Y. So alpha is equals to twice of Y. This will be the relation. Okay. But here it is given that this angle is 50 degree. This angle is here 50 degrees. So what will be the alpha first? That we need to calculate. Okay, student. So let us denote this angle as the alpha. Therefore, alpha is equals to 180
180 degree minus 50 degree.
minus
Linear
50.
pair.
Yes. So how much is this?
130.
130 degree.
180 minus 50 is our 130 degree. So it is the linear pair condition that we have applied here. Again, there is a relation that this alpha is twice of angle Y, because on the common arc AC it is formed, and common arc AC, so alpha is equals to twice of Y, since on common arc or on same chord or arc we may write AC it is formed, or same chord sometime also we are writing chord AC it is formed. So therefore we can apply this alpha is twice of Y. So alpha we have calculated. Okay, students. So just substitute this alpha here. So 130 is equals to twice of Y. So Y is 1 by 2 of 130. Go for dividing it just. It become how much? Yes, 65 degree. So this way this Y is calculated. So it's so simple, student. You have to just observe it carefully. Another thing, come to this Z. How this Z can be calculated and how this U can be calculated. A student, now you
Sir,
please apply
angle
the...
U equal to 25 degree.
Very good,
Where
because...
U is equal to 25 degree angles are
Isosceles
property.
triangle.
Very good, it become an isosceles triangle. So let me draw one more figure to explain it. So whatever the part required I am considering, that I will draw. So ACBO. A, C, B, center, O. Students, in this case, we have already calculated this angle as what? This was our angle X.
25 degree.
Yes, we have calculated this as 25 degree. Let me write here. Angle Y we have also calculated. Getting a student? 65 degree.
Yes, sir.
Now, let us come for angle Z.
Angle Z equal to 90 minus 25 degree.
90 minus
Very
5
good.
degree.
That could be the one thing. Or you may directly consider both of these are radius. So, whatever this Y, it will be same as this Z. That we can also apply. Okay? Since OA, sorry, OC is equals to OB, both are radius, therefore it is isosceles triangle.
Sir,
This implies angle Z is equals to angle Y, since isosceles triangle OBC, it is this one. In this triangle we are looking, and this we have already calculated. YS, how much? 65 degree. So it is like this one. Another property for getting this. Yeah, student, for getting this,
angles
what is
and
this
property.
denotation? This is our U. For getting this U, we can get
Angles and property.
very good angle sum property that we can apply, or directly X we have calculated. Also,
Isosceles triangle. Opposite
yes,
opposite angles
so
are equal.
OA
Opposite
is equal
angles of
to
triangle are equal.
OC in triangle OAC. Okay, student, in this triangle, if we are looking, observe this triangle OCA, this triangle, both of these are the radius. So directly we can write here OA, the angle in front of OA is your U, is equals to X. Now this
That is
X we have
25 degree.
calculated as 25 degree, it becomes 25 degree. Or the method 2 we can also apply, since
Angle sum property.
angle, very good, ACB is equals to 90 degree. Now this ACB is what? U plus Z is equals to 90 degree, and once Z we have calculated as 60 degree plus
U is
65 degree
equals
is equals to 90 degree. This way U is equals to how much? 25 degree.
25 degree.
So student, my purpose from last day and today is to make you understand how to analyze the angle. Angle is very important in circle as well as in your line and angles and in triangle. Okay, student. So be careful for the property like isosceles, semicircle, the angle at center and angle at the circumference, these things. Okay, student. So you should be careful for that. Angle on the same arc are equal, like here V we have calculated by equating this angle on same arc, on same arc BC. Okay, student. So these are the important thing of this circle. That's why I am emphasizing. So this was all about making the angles. Now let us go for the new topic. Angle made by the bisector or the perpendicular drawn from the center to a chord. So let us go for that. So right, perpendicular on a chord from center. Okay, student, it is this one. In this case, we are given with a circle. Let us consider this is a circle with center O. Let us consider AB as one of the chord. Getting? Now we want to draw the perpendicular from O on AB. So draw perpendicular means 90 degree on AB. Perpendicular, let this perpendicular intersect at point M. So this is 90 degree. This we have drawn. Then it can be proved that this AM is equals to MB. Means the perpendicular from the center on a chord bisects the chord into two equal parts. That is the thing that we want to prove. So write down the theorem. So it is in the form of theorem. So student, the theorem is like this. Perpendicular from center on a chord bisects it into two equal parts, or simply bisects it into two equal parts, or divide it into two equal parts. Okay, bisect simply means it is dividing it into two equal parts. So what is given here? We have constructed the perpendicular from the center over a chord. Then we have to prove it is bisecting. Okay. So student, this proof is sometimes also asked. So how is the proof? This is also important to understand why this is bisecting. Let us consider a chord AB and the center O. From O, the perpendicular drawn on AB, let this perpendicular be AM. So students, let AM perpendicular on AB. So let OM perpendicular on AB. Why? This is drawn. So while this is perpendicular, what does it mean? It simply means the angle AMO is same as angle BMO, and each angle is how much, students? 90 degrees. Is it okay? It is one thing. Drawing perpendicular simply means this much. Now we have to prove, what we have to prove? We have to prove that AM is equals to MB. This we have to prove. Okay. For this, you have to construct a triangle. So write down the construction. So join OA and OB. So after joining, what it become? OA and OB.
Is a radius.
Very good. So while we are joining, these are the two radius, therefore these two will also be equal. Okay. Now let us start the proving. Here we can prove, or we can take the two triangle, because we have to prove AM is equals to MB. So these two segments can be proved equal by the concept of congruency only. Here in geometry, how the two segments can be proved equal? By congruency, if the triangle is formed. So one side you have to take in triangle AMO, and other side in triangle BMO. Okay, these are the two triangles that we are taking. Okay, let me draw this as the separate one, though they are touching. So this point is O, this point is M, O and M, but this point is B, this point is A. Yeah. So what we are getting as students here? What are the equal things?
to OB.
Very good. So the condition of congruency we are going to apply here. It is given that these two are 90 degrees. So right, triangle AMO, right, for this on one side, that we can write here angle AMO is equals to angle BMO. Why? Each equals to 90 degree. It is by construction, means it is given. rather than construction. It is the given condition.
OM is common.
Very good. Another one is our what? OM is equals to OM. This is common. What else is there?
AO
Yes,
equal to
student?
OB, radius.
OA is equal to OB.
Okay. OA is equals to OB. Why? Both
Radius.
are radius.
Radius.
And students, which congruency criteria is satisfied?
ASA.
ASA.
Observe carefully. OA is equal to OB. Means what these two are? These two are
RHS.
the, yeah, for a right angle triangle, what is this? Hypotenuse, students, of two triangle. Another right angle, these two. Then what is this? These two sides are also equal. So which criteria is satisfied in right angle triangle?
RHS.
Yes, it is called as RHS. Okay, right angle, hypotenuse, and one of the side. So by
Right.
RHS, triangle AMO will be congruent to triangle BMO. Why? By
RHS.
RHS congruency. Please go through the previous videos if you people are missing. Okay, or it is exactly same as our SAS, but written in different way exclusively for right triangle. So while these two triangles are congruent, therefore we can write what is the remaining part which is not equal or not given as equal. It is our AM will become equal to BM by CPCT. Okay, thus AM is equals to BM. It is proved. This was to be proved and it is also proved. Okay, student. So this way we have learned that the perpendicular drawn from center to a chord bisects the chord. It is very important. Though this we will use in different form at different places. But be careful, do not forget this. It is this one. Now, let us go for the other criteria. Or also, a student, what can be applied here? What else is there? So, right, other relation for the chord length and its distance from center. A student, it means we are given with a circle. For this circle, we have a center O, we have a chord AB, we are given with a chord length. Let us call this length A to B as, let us call this chord length as Y. The perpendicular drawn from O on AB, let us call this perpendicular is touching this AB at point M. Then we have learned that AM is equals to MB. Let us also write or consider this OM length as the small p or x rather we can take. Now, OA, what is this OA, student? OA is Yeah, radius of this circle.
Radius.
Getting? It is this one. So here, triangle in right angle triangle, because it is the perpendicular that we have drawn, triangle OMA. Getting? So how is our OMA triangle, students? Let us draw it once again. The point is O, this point is M, this angle is 90 degree, this point is A, OA is our radius, OM is our distance or length X. A student, can you tell me what will be the value of AM? Yes? From this figure, what is given? AB is given as Y and M is the midpoint of AB. So what will be the length of AM?
Half of AB.
Good. It is half of AB. Whatever we have proved right now here, AM is equals to MB, means these two lengths are equal and this AB is the complete length. So therefore here we can write as this AM is equals to BM, this is equals to half of AB. Get it? So this relation we shall keep in mind. How we are getting? AM is equals to MB, since AB is what? AM plus MB. But these two are equal, so we can write AM plus AM. In place of BM, we can write AM. Twice of AM is equals to AB. So AB by 2 is AM. Now this AM is also equals to BM. So AM is equals to BM is same as AB by 2. So this is how we are proving. A student, these are the common thinking. You must start thinking mathematics rather than just mugging up. Many times I'm emphasizing mathematics doesn't mean you just remember the things. No, you analyze, you start thinking. Once you start thinking, you become habitual. The mathematics is very easy. Every time, are we doing anything? Nothing we are doing. Whatever the basic thing, when it become equal, when congruency is existing, those things we are applying. The simple mathematics we are applying. But ultimately, these things we have to apply in the question. So this way, each of this segment, sorry, the part AM is equals to MB. Here, AM can be written as how much? AB by 2. So this is our Y by 2. Okay, student. Now in this right angle triangle, the hypotenuse OA square is equals to AM square plus MOA square. Is it okay? Surely. Why? By Pythagoras theorem. Good. It is nothing but it is our Pythagoras theorem. It is this one. Now here OA is our radius square is equals to Y by 2, whatever the length is given, that square plus X square. Okay. This implies even the distance. So this is basically the exact relation that we need to keep in mind. Or X square means distance from the center to the chord, that is X, plus half of the chord length, their square, means Y by 2 square is equals to radius square. It is this relation that we need to keep in mind. Okay, student? It is like this. So based on this question or this simple relation, the questions are framed. So let us take one question. So find the length of chord of a circle of radius of radius 5 centimeter at a distance of 3 centimeter. Students, are you getting what does it mean? You have to find the length of chord to whom a circle whose radius is 5 centimeter, but this chord is at a distance. And if you are getting have any ambiguity, then you may write the chord at or the given chord. So this chord is at a distance of 3 centimeter. Means what? We are given with a circle of radius, how much? R
5
is equal to
centimeter.
5 centimeter. Okay, student, it is this much. Then we have to find a chord whose length or whose distance from the center is given. So, a student, this perpendicular distance from the center to a chord or perpendicular drawn from the center to a chord and distance from the center. So, distance from center always means it is the perpendicular length. It is the perpendicular length from center to chord. Center to a chord. That is called as the distance. Okay. So, in this case, we are given with the distance. This distance is over 3 centimeter. And with this, a chord is drawn. We have to find the chord length AB when the center O and this M. So this OM is given here. What is given here? We can write OB is equals to radius. This is about 5 centimeter. And OA is equals to how much? It is given, student, perpendicular. No, it is same as a radius. So whether you write OA or OB, it is same as a radius. You may also write this as this way. But here we are given with OM, which is how much? 3 centimeter. What is required? What is the length of AB that we need? Students, what is the length of AB? AB.
Half of MB is equal to half of AB.
Yes. So AB is twice of AM or twice of BM we can write. Okay, because these two lengths are equal. So AB is equals to twice of AM or the same as twice of BM.
BM.
So if we are able to calculate this BM, then AB can be calculated. Otherwise, no direct relation between AB and the given radius and perpendicular distance. So first we need to redraw the triangle. So draw it in triangle OMB. You just draw it. OMB is the triangle that we need to draw. O, M and B. Okay. Here this is about 5 centimeter. This is 3 centimeter. This MB basically we want to know. So see, since OB is the hypotenuse in this right angle triangle, their square is equals to OM square, this perpendicular square, plus MBA square.
B square.
Now OA is given as 5A square. This is 3A square plus MBA square. So it is 25 is equals to 9 plus MBA square. Bring this on the left hand side to calculate this MB.
So
So what will
9
be
minus
MBA
25.
student?
9
Yes,
minus 25.
25 minus 9. This is the square basically. So MBA, that we have to take the root of this. 25 minus 9 is 16. Getting? So
16.
MB value is our 4. The square root we need to take, okay, for removing the square. So it is 4 centimeter. But what we need? The chord length. Chord length is twice of MB because M is the midpoint of chord AB. So twice into 4. So answer
8
is your 8 centimeter.
centimeter.
Getting a student? So these way very simple questions are framed on applying the Pythagoras theorem for the relation between the distance of a chord from the center and the radius of the circle. Okay, student? A student, we have learned the important thing. What we have learned? Perpendicular drawn from the center to a chord bisect. There is another way of stating this theorem. If we draw perpendicular bisector of chord, then surely it will pass through the center. That is the converse of this. Okay? So even the converse of this is also true. So write reverse of this, or we can write, and we will take it together on the next page also. So this can also be stated, or the reverse is also true. Perpendicular bisector. Okay, student? This time we are taking the perpendicular bisector, not only perpendicular, because on this length we can draw perpendicular here also, but drawing it in the middle, this is the perpendicular bisector of AB. Okay, so this bisector will pass through the center O. That is the other way. So perpendicular bisector of a chord passes through its center, because it is the chord, means it is of the circle. So this is the reverse of this theorem. So let us go for understanding or proving the reverse one. So this is our theorem number 2 basically, or 1, 2 we have discussed earlier. This will be the 4 if we are in count. The perpendicular bisector of a chord passes through the center of the circle. It is this one. Okay, so how is this? It means we are given with a chord AB. Students, it have a center O. Draw perpendicular on AB. I may draw here also. Perpendicular simply means it is 90 degree. This is also other perpendicular. This is also other perpendicular. But here we are observing that these perpendicular are not dividing AB into two equal parts. Means if we are just taking one of the perpendicular, say this is the perpendicular, which is cutting AB at point M. Is this AM equal to MB? Is this? No. Then though it is perpendicular, but it is not the bisector. So our point is perpendicular, bisector we need to take. It should be perpendicular as well as it should be bisector. So how much perpendicular bisector we can draw? One and only one.
One.
Okay, students? Sorry. So one and only one perpendicular bisector can be drawn here. So what is that perpendicular bisector? A
From
point
radius, sir.
in middle of this. Okay. From this you are going to draw or take a scale and draw the perpendicular. Then
Midpoint
you
of
will
the-
observe that here we are observing that it is passing through the center O. Okay, students? It is this one. So this is the theorem. If this is 90 degree, then it is this one. So even proving is the same as earlier one. Why? Again, you need to, here we have this AM is equals to MB. So what is given here? AM is equals to MB, and at the same time angle AMO is equals to angle BMO, because it is perpendicular drawn. These two things, perpendicular bisector includes these two things. So we have written here given. Also by construction, if we join OA and OB, so right, also what we have, a student, if we join OA and OB, then this will also be equal, but we need not take it equal because the center O we have to determine. So what we shall consider? We shall consider OM is equals to OM on both sides because it is the common. Therefore, triangle AOM student on left hand side is equals to triangle BOM, by which it is our, this is common, these two are equal, so SAS congruency. By SAS congruency, these two are congruent. While these two are congruent, it means we can write OA is equals to OB, and these are the OA and OB are the length from the 2 points on the circumference, and these two lengths will surely be touching the center because it is forming a right angle triangle. So right, so this is equal to radius. So this implies MO passes through center. Okay, it's so simple kind of thing, a student, you have to just observe it carefully, you can get it. Okay, it is one thing. Now students, many a time it may be possible that we can extend this to the circumference. Means what? Right, extending perpendicular bisector to circumference. When this is extended to circumference, then how it appears? Students, let us consider a circle with center O and chord AB. Now we are drawing a perpendicular bisector which is Dividing this means from O to A. Now extend this to this point. This is our M. Consider this point as P. Okay, student? Then what are the relation that we can write? Students, here in this case, joining O to A, it is our radius. Is it okay? Okay, no?
Yes.
If we consider the chord length, then this chord length, we can write this as the Y, then this much length become Y by 2. This we can write. Even O to M sometime may be given, it could be our X. Okay. Now, one right angle triangle we can frame here is, so in right triangle AMO, what could be the relation, student? OA square is equals to AM square plus MOA square.
M square.
Good. So we can substitute in the term of R, Y by 2 and X. We are not worried for that. So this could be the one relation, or we can write it here. R square is equals to OM is our Y by 2. So put this as Y by 2 square plus X square. This is one relation. Also, here we have extended this O MO to P. So we can take the other triangle. What is that? APM. Can we take? In this triangle, a student, observe it carefully. Now we are going to take the triangle A, P and M. This triangle, this orange triangle. Here again we have this right angle. Getting? So therefore, in this triangle we can write triangle AMP. Again, angle M is your 90 degree. So therefore, what will be the relation here? What will be the chord length? The other chord length AP. AP will be how much, students? So student, AP is the new chord length or the other chord length.
AP
that
square is equal to
Very good. So AP square is equals to how much, student?
AM square plus MP square.
Very good. So it is our AM square plus
MP
MP
square.
square. Student, what is our AM? AM is Y by 2. So this square we may write. But what is our MP? Student, MO is our X. What is our OP? OP length is how much? O to P. What is our OP? O is center and P is a point on the circumference. So what will be the length of OP? Same as radius, student. So this much length is radius. So what is our MP length? MP length is X plus R. Getting? This is another important point that you will come across while solving the question.
OM plus OP.
Good. R plus, sorry, X plus R, their square. So this way the AP square can be calculated by knowing the length of one of the chord and their perpendicular length. So if it is going to intersect at the other, what it will be, we can determine. So this was all about this chapter. Student, there is another a very small thing that is called as equal chords of a circle. So equal chords of a circle. So whether you write equal chords of a circle or equidistant chord. A student, how many equal chord can be drawn? Any number of equal chord can be drawn. A to B, I may draw another one. CD, it may be possible that AB is equals to CD. Okay, but if we join or if we draw the perpendicular, from the center to this chord or perpendicular bisector of this chord, it will pass through center. Or if we draw perpendicular from the center O over this chord, then we can get, let us call this as M, and the other perpendicular on the other chord as N. Okay, student? So here noticeable point is that if AB is equals to CD, then the perpendicular length of AB from the center, what is that?
OM is equal to M.
Will
OM is
also be
equal to
equal
N.
to
ON.
ON. This is one way. Means equal chords are at equal distance from the center. Or the other way, if you want to draw the chord at equal distance from the center, then the chord will also be equal. Means what? If we are considering a circle, we are taking a length, certain length. From here we want to draw a chord, and with the same length x, if we are taking the on other side, and here this is also x, and you want to draw the other chord, let us call this as PQ, and this as RS, let us call this as O, and this as M, this as N. So if your OM is equals to ON, then the chord length PQ will also be equals to the other chord length RS. Okay, student? So these two are the conditions. So what does it simply mean? It simply means chord of equal length are at equal distance from the center. This is the distance from the center. Means perpendicular drawn from center over the chord is called distance of the chord. Okay? So write down that theorem. So equal chords, or we can write here, equal chords are at equal distance from center. Means here we were given with AB is equals to AC in first figure. Therefore, its distance from the center O means OM and ON are equal. This is the condition. What does it mean? Means chord at equal distance from the center are also equal. So this is the condition that where the chords at equal distance from center means the distance OM and ON is given are equal. Means if the distance OM is equals to ON, then the chord PQ will equals to RS. So these are the other two things that we have to just understand. Okay, student. There is another small thing called concentric circle. Concentric circle is nothing but it is the term. So two or more circle having same center, they are called as concentric circle. Example, consider the point O. Considering this point O, you have drawn one of this circle, okay, with some radius R1, but same center, but of the different radius. If you are going to draw, you will get another circle. Okay, so this is your R2. Means same center O, but different radius. It is this. Okay, so this way the chord can be drawn for this one also. Means what, student? It is possible that you are given with this circle and you are given with another concentric circle. Then you are drawing a point or a chord. So in this case, O is the center and it is for the radius R1. This same center, the bigger circle with the radius R2 is we have drawn. So it is the concentric circle where this AB is the chord for bigger circle, but it is touching the internal circle at point M. So in this case, what is this chord length? So first determine MB. So MB, how this MB can be determined, student? So MB, you have to take the triangle MBO. In this triangle, what we have? This OB is the bigger triangle, student. If you have doubt, you may write this triangle separately, where this is our radius R2, this is our R1. This point is at the center, so it will be perpendicular, though it is just touching the internal circle. Then this length is our MB and this point is our O. So OB square is equals to OM square plus MB square. Are you getting? OB is what? R2, their square is equals to OM is what? R1 square plus MB square. Means R2 square minus R1 square is equals to MB square. So sometime this MB, this chord length, just one part of this chord, means half part, can be determined by taking the under root of R2 square minus R1 square. The value will be given, you will put it and you will calculate it by the same method. Therefore, the chord AB is equals to twice of MB. It is obtained by substituting R2 square. Okay, student. So sometime, I mean, in your question, it will be given. Getting? R2 will be given, R1 will be given. It is in your textbook. So please try this. So this was all about the concepts that we have solved or we have to apply in this chapter. We are left with only one topic called cyclic quadrilateral. So tomorrow we will finish it, and if the time permit, we will do the revision of mathematics or we will go for the science. So only a small topic that is called as the cyclic quadrilateral. Now you have to do the homework. Write down the homework. A student, you are able to solve all kind of questions. So in each of our exercise, it is our 10 point or 11 point. Exercise number
10.
Yes. So it is our 10.1 you can do, 10.2 you can do, 10.3 you can also do. Excluding the cyclic quadrilateral, you can do all this. So please finish this and try with our RC exercise 1. You can get it. If you have doubt, let me just give you some hint. Students, excluding the cyclic quadrilateral, see, in this case, it is given that two circle of radius 5 cm, 3 cm intersect at 2 point. Distance between their center is 4 cm. Find the length of the common chord. Okay, so you will draw the two circle. They will just intersect. Means it is like this one. Means intersecting of two circle. It is based on this. Intersecting of two circles. What is the concept? Let me quickly just give you some hint. Say this is one circle, this is other circle. This circle need not be of the same radius, they may be of the different radius. Let us consider this center as O1 and this have the center as O2. Okay, student. Now here this length may be given. Okay, student. Here the point where they are intersecting, let us call this as AB. Then you will find that this AB is always perpendicular to your O1, O2. O1, O2 is the point. Okay, it is one thing that you need to keep in mind. Now, how this O1, O2 and what are the relation? Here, O1 to A, what is this? This is the radius 1, and A to O2, what is this? It is our radius 2. Getting a student? So it is this way you have to just apply. Here you can take this chord length as x, this chord length as x, or let me take the half part of this as x, where they are intersecting as m, other as x. It may be, we may consider this to this one as y, or the entire length may be given, or this O to M may be considered as A and this as B. So student, in this case we have the triangle, right angle triangle, we need to apply the Pythagoras theorem. In triangle O1AM, means which triangle I am talking? O1A and M, this triangle. Okay, student? In this triangle, what will be the relation? R1 square hypotenuse is equals to AM, means x square, plus O1M, means it is our A square. Okay, this will be one relation that you have to put and you have to solve. Similarly, you need to take the other triangle. In triangle O2AM, what we have? We have now the R2 on the other side. Now we have the R2, this length, this as B and O2M as X. So here we can write R2 square is equals to the length X square plus B square. So these will be the two relation that you have to write, and you have to find the unknown quantity. So the length between O1, O2 is given, then you may consider some as X and you can calculate it. So please try this. So it is based on this concept, you can get it. So two equal chord within the circle, prove that the point joining intersect the center, equal angle, the same thing like we have proven now, perpendicular bisector, that way you can prove it. So these questions are very easy. See here only 3 questions. Different part of, draw different part of the circle. How many points does the pair have in common? That is maximum number, means 2 or 3 that you have to told. This we have already done in our last lecture. See here also 2 questions only. These are question. You can do it. In question number 1 we have already done. 2, only 2 questions. You can do it. 3, is also very important. Please do it. 10.4, some of the question I will solve tomorrow. Then in 10.5 is the most important. In this, up to 5 questions we have already done.
Sir, Sir, are you speaking?
Sorry, student, it was a network issues. That's why I got disconnected. So, students, so this is your homework. Getting? So you please finish this homework. I have already posted in your WhatsApp also. So please finish this, and tomorrow we will again at the same time. Okay? We will finish this chapter, and if possible, we will do the revision also. Okay, student? So thank you, student. If you have any doubt, then you may please ask. Otherwise, we
No
can
doubt, sir.
stop the class here because I have to go for class 10.